Dear students, in the last lecture we started Fourier series, okay, and we did some basic concept of Fourier series and some formulae, okay. I hope you uh, revise all these things, okay. Now today we are going to do some problems based on the Fourier series. Example, okay. Find the Fourier series of find the Fourier series for the function. Your function is given to you, f of x equal to x in the interval. Your interval is 0 to 2 pi, okay. We have to find the Fourier series of the function f of x in this interval. So what are the basic needs of the function to find the Fourier series? What are the basic needs? Yes, can you tell me what are the basic needs? So let us start how to solve this problem, okay. First we write down given function. Your given function is what? F of x equal to x in the interval 0 to 2 pi. This function is given to you, okay. But our job is what? Our job is to find Fourier series of this function, okay. So let, I am writing here, let f of x equal to a naught plus summation running from n equal to 1 to infinity a n cos n x and plus summation running from n equal to 1 to infinity b n sin n x, okay. B n sin n x, b n sin n x, and name this equation number star, okay. We name this is equation number star. So now our job is what? Our job is to determine the Fourier coefficient of this expression. What are the Fourier coefficients? A naught, a n and b n are the Fourier coefficient. So for this we will have the formula for the Fourier coefficient, okay. So what are the formula for that? Where a naught is what? A naught is 1 upon 2 pi integration of limit 0 to 2 pi f of x dx, okay. And write down all the formula first. And an, your an is what? 1 upon pi integration of limit 0 to 2 pi f of x and cos n x dx, okay. And for bn we will have 1 upon pi integration of limit 0 to 2 pi f of x sin nx and dx, okay. These are the formulae, and we will use each formula to determine a naught, a n and b n, okay. Now our job is what? To find a naught. Your a naught is what? Now to find a naught, to find now to find a naught, a n and b n, okay. So let us find one by one. A naught is equal to 1 upon 2 pi integration of limit 0 to 2 pi, and f of x, your f of x is given to you, that is x, ex and dx. Just integrate this. So 1 upon 2 pi integration of x is what? X square by 2, and providing limit 0 to 2 pi, okay. Providing limit 0 to 2 pi. Just simplify this. So we write here this equal to what? 1 upon 2 to the 4 pi x square and providing limit 0 to 2 pi. Getting? So this can be written as 1 upon 4 pi. 1 upon 4 pi. Upper limit is what? 2 pi. 2 pi the whole square and minus 0 the whole square. Okay. So this can be written as 1 upon 4 pi, and this is 2 to the 4 and pi square. So यहाँ से 4 pi and 4 pi cancel, 1 pi is remaining. So we will write here pi only. Okay, you will write pi. So your a naught will be what? Your a naught will be pi. Okay, so go to the next page. Therefore we can say that a naught equal to pi. Just put this in the bracket. Okay, now also we find an. A also, what about the an? Your an is 1 upon pi integration of limit 0 to 2 pi f of x cos nx and dx. Okay, so this is equal to what? 1 upon pi integration of limit 0 to 2 pi, but f of x is what? Your function x, and we write cos nx dx as it is. Okay, so this equal to 1 upon pi. Here we will apply generalized integration by part. Okay, so before this we must arrange the given function, means this function, into Lie form. What about the Lie form? L stand for logarithmic, I stand for inverse, A is algebraic, T is trigonometric, and E is exponential. Now let us observe whether this function is in Lie form or not. Say A is algebraic, okay. Then cos nx is trigonometric, A and T, okay. This is already in Lie form, so no need to arrange this function in Lie form. Okay, just apply the generalized integration by part. So applying generalization integration by part. So your first one is what? U. Second one is v. So we write here u, that is x, u x, and integration of v. What is the integration of v? Sine nx divided by n, and minus derivative of this u, that is 1, and integration of this. What is the integration of sine? That is minus cos nx, okay, divide by their coefficient n, or n is already here, so this become n square. Okay, now providing limit 0 to 2 pi, so this equal to what? 1 upon pi, and just apply the upper and lower limit. Before that we just simplify this. So x sine nx divided by n, and minus goes here, plus cos nx by n square, and dividing providing limit 0 to 2 pi. Okay, so this equal to 1 upon pi upper limit. Your upper limit is what? 2 pi, and sine 2 n pi. Okay, sine 2 n pi. Instead of here x, we putting here 2x, 2 pi, so this become 2 pi n by n, and my plus cos 2 n pi by n square. This is for upper limit. Okay, this is for upper limit. Similarly provide the lower limit. 0, instead of x we putting 0, so whole thing will be 0. Okay, and plus cos 0 by n square. Okay, now close the bracket and main bracket also. So this equal to 1 upon pi, open bracket, just simplify this here, cos 2 n pi. We know very well what is the cos multiple of pi is always 0. So this is what 2 pi and 0 and plus cos multiple of 2 pi is always 1. So this become what 1 upon n square. Okay, and minus this is 0 but cos 0 is 1, so we write here 1 upon n square. Okay, so see here, so this 1 by n square minus 1 by n square will cancel, positive negative will go on, and multiply by 0. Multiply by 0 means ab 0, so 1 upon pi here 0, so you will get what 0, you will get 0. So therefore we can write an equal to what 0. Your an is 0. Okay, now our job is to find a bn. Now we will find the coefficient what bn. Okay, for this we will have formula for bn. Therefore bn equal to 1 upon pi integration of limit 0 to 2 pi f of x sin nx and dx. Okay, so this equal to 1 upon pi integration of limit 0 to 2 pi. Okay, f of x, what about the f of x? Your f of x is what x, and sin nx as it is, and write down dx. Again here we will apply generalized rule of integration by part. Okay, so this is u and this is v, and we before integrating this we first observe that whether this function is in Lie form or not. If so, then apply generalized integration by parts. If not, then we must arrange the given function in what Lie form. Okay, so this is equal to 1 upon pi. Okay, 1 upon pi, here u is x and v is this sin nx. So u, that is x, integration of sin, that is what minus cos nx, and divide by their coefficient is n. Okay, and minus derivative of x is 1, and integration of cos nx by n. So integration of cos is sin, that is minus sin n x, and divide by their coefficient n, but n is already here, so n and into n, that is n square. Okay, now close the bracket and providing limit 0 to 2 pi. Okay, so this equal to what 1 upon pi, and just write down this x into cos nx by n, and minus minus goes plus sin nx by n square. Okay, and providing lower to upper limit 0 to 2 pi. Okay, so this equal to 1 upon pi, just providing the limit, upper limit minus 2 pi. Okay, into cos 2n pi by n plus sin multiple of pi 2n pi by n square. This is for what? This is your upper limit minus lower limit. So instead of x we putting 0, so whole thing will be 0 minus, no, here plus sign is there, so we writing plus, and sin 0 n by n square. Okay, just close the bracket, just solve this. So this is 1 upon pi. Okay, and minus 2 pi cos 2n pi is cos even multiple of pi is 1, so this become what n, this become n. Okay, and plus cos sin multiple of pi will be what 0, so this become 0, and minus sin 0 is 0. Okay, So just simplify this. So this is what minus 2, this become 1 upon pi into minus 2 pi by n. Okay, so this pi and this pi will cancel. You will get minus 2 by n. Okay, so therefore you can say that bn equal to what? Minus 2 by n. So this is your coefficient bn. This is your coefficient bn. Now putting all the coefficient, that is what known as Fourier coefficient, in equation number star. So putting all the Fourier coefficient, putting all the Fourier coefficients in equation number star, we get
सर वो लाइन नहीं था सर
yes,
आपने कहा 1/पाई -1/2 पाई +0 -0 सही वाला नहीं समझ आया कैसे आया
1 upon pi कहाँ से? स्टेप नंबर
यस सर नीचे से सर पहला
नीचे से पहला
नहीं सर फिफ्थ नीचे से फिफ्थ
1 2 3 4 5 ये वाला
फोर 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 वाला
4 ये वाला यहाँ से
सर नीचे से 4 वाला
तो ये हुआ ना नीचे से 4 वाला, मतलब कि
ओ,
1 2 3 4 यहाँ से
यस सर
ये नहीं समझा?
नो सर
चाहिए देखो, on yesterday we have written that what cos even multiple of pi is what always 1 होता है. Cos even multiple of pi, that is cos 2n pi is equal to what 1. Okay, and sin multiple of pi is always 0. Sin का कोई भी multiple हो, that is will be what 0. Sin n pi equal to what 0. Sin n pi 2 pi 3 pi कोई भी pi रहेगा, that will be your 0. Getting? This is your result. You must remember this. And sin 0 is 0. Okay, here 0. And sin 2n pi, if n is 1 here, so that becomes sin 2 pi, but sin 2 pi is what 0. Okay, now understood this?
यस सर
Okay, now see, now putting all the Fourier coefficient in equation number star. Which one equation number star? Where is this? Equation number star is this one. Substitute all the coefficient in this equation, in this expression. Putting all the Fourier coefficient in equation number star. Okay, so we get f of x equal to a naught. Your a naught is what? We found a naught. A naught is pi. A naught is pi, and plus summation running from n equal to 1 to infinity. What about an? What about an? An is 0. An is 0 cos nx. Okay, and plus summation running from n equal to 1 to infinity. Bn is what? Bn is negative of 2 by n. Okay, and sin nx. Okay, let us simplify this. So you will get what? Therefore we have f of x equal to pi and minus, this will 0, and plus sum running from n equal to 1 to infinity, and minus 2 by n sin nx. Okay, let us simplify this more. So this equal to pi minus 2 is constant, I'm taking outside, minus 2 sum running from n equal to 1 to infinity sin n x upon n. Okay, sin nx upon n, or you can run this series pi minus 2. Okay, for n equal to 1, you will get sin x by 1. Okay, and plus n equal to 2, you will get sin 2x by 2, and for n equal to 3, you will get sine 3x by 3, and plus, and so on. Why so on? Because this is the infinity, so just sum running up to infinite many terms. Okay, so you can say this is the required Fourier expression or Fourier series of the given function. So which is required Fourier series of the given function. Okay, so this is required Fourier expression of the given function. I hope you understood how to find the Fourier series of the given function. Yes or no, students? You got it?
Yes,
Yes,
sir.
sir.
Example number 2. Move to the next page. Next example. Next example. Uh, obtain the Fourier series for the function. Obtain the Fourier series for the function, or you can say of the function your function is given to you, that is f of x equal to 1 by 2 pi minus x in the interval 0 to 2 pi, and after this, hence hence deduce that deduce that pi by 4 equal to 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus, so on and so on. Okay, so let us see how to find Fourier expression of the given function. Okay, solution of this. Deduce that means what? We will find this expression by using Fourier series. Okay, obtain Fourier series, we will find this expression. Okay, so let us start. So what is our first step? We just write down given function. What is the given to you? F of x equal to 1 by 2 pi minus x in the interval 0 to 2 pi. This function is given to you. Now our job is what? Our job is to find Fourier expression. So let f of x equal to a naught plus sum running from n equal to 1 to infinity a n cos nx n plus sum running from n equal to 1 to infinity bn sin nx. Okay, let our required Fourier series be this. Name this equation number what? Star. Name this equation number star, where a naught, a1, a naught, an, and bn is to be determined. So where a naught, an, and bn are to be determined. मतलब क्या? We have to determine the value of a naught, an, and bn. Okay, let us find one by one. Okay, let us find one by one. To find a naught first. Okay, to find a naught, an, and bn. Okay, so let us find one by one. A naught, since A naught is what? 1 upon 2 pi integration of limit 0 to 2 pi f of x dx. Okay, and this is equal to what? 1 upon 2 pi 1 upon 2 pi integration of limit 0 to 2 pi f of x. Here f of x is 1 by 2 1 by 2 pi minus x and dx. Okay, so 1 by 2 is constant, take outside, this become 1 by 4 pi. Okay, and integrate this pi. Okay, integration of dx is what? X minus integration of x is what? X square by 2. Now providing limit 0 to 2 pi. Okay, so this equal to 1 upon 4 pi and provide upper limit, that is pi into 2 pi minus 2 pi square by 2. This is for what? Upper limit minus lower limit. Instead of x we putting 0, so whole thing will be 0, and minus second term, instead of x square we putting 0, the whole thing will be 0. So this write 0 minus 0. Okay, and close the bracket. So this equal to 1 by 4 pi. Okay, and just simplify, 2 pi square minus 2 to the 4 pi square by 2. Okay, this will 0, no need to write. So this equal to 1 upon 4 pi. Okay, just cross multiply, 2 to the 4 pi square minus what? 4 pi square by 2. 4 pi square and 4 pi square, this will what? 0. So 1 by 4 pi minus 0 become what? 0. Minus 0 become 0. Minus 4 pi square. So this becomes 0. Okay, so your a naught is what? Therefore we can say a naught equal to 0. You understood this? Yes or no?
Sir.
You got it? Okay. You got it? How to find the value of a naught? Now let us find next Fourier coefficient. Also we have bn equal to what? 1 upon pi 1 upon pi integration of limit what? 0 to 2 pi f of x cos. Before that we determine what? An, then we go for bn. So this is what? An. So 1 upon pi integration of limit 0 to 2 pi f of x cos n x and dx. Okay, dx. Getting? Now this equal to what? This equal to 1 upon pi integration of limit 0 to 2 pi. But f of x, what is the f of x? Your function is what? 1 upon 2 pi minus x. Just substitute over there. 1 upon 2 pi minus x and cos nx dx. Okay, so this equal to what? This, see here, 1 upon 2 is constant, we taking outside, so this become what? 1 upon 2 pi integration of limit 0 to 2 pi and pi minus x and cos nx dx. Okay, so before integrating this we must arrange this function as a Liat form. Liate. What about the Liat? L stand for logarithmic function, I for inverse, and A for algebraic, and T is trigonometric, and E is exponential. So we must observe whether this function is in Liat form or not. So this function is already in Liat form, so we don't need to arrange this function as a Liat form. This is already in Liat form. Okay, so here algebra is first and trigonometrics later. Okay, so just integrate this by using generalized integration by part. So this equal to what? 1 upon 2 pi This first term is u, second term is v. So we write u, that is pi minus x integration of v. Integration of cos is sine, that is what, sine n x divided by their coefficient n. Okay, and minus derivative of u. Derivative of u is pi. Derivative of pi is 0 and x is 1. That is will be minus 1. So here minus 1, and integration of this expression sine nx by n, that is what, minus cos nx. Okay, and divide by n, but n is already here, so this become n square. Now close the brackets. Okay, don't forget to close the bracket. Why is this so? Because there is minus sign, so this become dangerous. Okay, so this, you must close this bracket over here. Okay, and now put limit 0 to 2 pi. Okay, so this equal to 1 upon 2 pi. 1 upon 2 pi. Just before applying the limit, just simplify the bracket first. So pi minus x. Okay, and sine n x by n, x by n, and minus minus goes plus, and again minus sign here. Okay, so this is minus sign, minus minus plus, and minus sign is here, so we have minus sign. We write here cos n x by n square. Now provide limit 0 to 2 pi. Okay, so this equal to 1 upon 2 pi, and we first providing upper limit. What is the upper limit? 2 pi. So we write here pi minus 2 pi. Okay, and sine 2n pi by n. Okay, minus cos 2n pi by n square. Okay, so this is for upper limit minus lower limit. So instead of x we putting here 0, so this become pi minus 0 and into sine 0 by n, and minus cos 0 by n square. Okay, cos 0 by n square. Just close the bracket and simplify this. So 1 upon 2 pi. Okay, see here, sine multiple of pi is what? 0. Okay, so this becomes 0. There is no need to simplify this. Okay, or just simplify for sake of convenience. For sake of convenience, just simplify it. So this is what? Minus pi, and this becomes 0, and minus cos even multiple of pi is always 1, so this become 1 upon n square. 1 upon n square. Okay, just provide the bracket over here, and minus sine 0 is what? 0, so this become pi 0 by n. Okay, and minus cos 0 is what? 1, so this write 1 by n square, and write down one more step. So 1 upon 2 pi, 1 upon 2 pi, 0 multiply anything is what? 0, minus 1 upon n square. Okay, 0 multiply by anything is 0, so we write here minus 0, and this become plus. This become plus 1 by n square. Okay, 1 by n square. So this equal to what? 1 upon n square and plus 1 upon n square. So this become what? 1 upon 2 pi minus 1 by n square and plus 1 upon n square. So this and this gone, so this become what? Whole thing will be 0. So from this we got a n equal to what? A n equal to 0. From this you got a n equal to 0. Now our job is what? To find the next Fourier coefficient. What is that? We have to determine the Fourier coefficient Bn. Okay, so let us move to the next page, then we will determine. Now you understood now how to find the Fourier coefficient of An? Let us find the next Fourier coefficient. So that is what? Bn. Bn equal to what? 1 upon pi integration of limit 0 to 2 pi f of x and sine nx dx. Okay, So this equal to 1 upon pi integration of limit 0 to 2 pi. But f of x, what is the f of x? Just substitute the value of f of x. Your main function is what? Your main function is 1 upon pi, sorry, 1 upon 2 pi minus x. 1 upon 2 pi minus x, and here write down sine nx and dx. Okay, sine nx and dx. So this equal to 1 upon 2 is constant, we taking outside, so this become 1 upon 2 pi. Okay, 1 upon 2 pi integration of limit 0 to 2 pi and pi minus x sine nx dx. Okay, so just observe whether the function is Lie form or not. It is already in Lie form, so just integrate it by using generalization integration apart. So 1 upon 2 pi. Okay, 1 upon 2 pi, this is u and this is v. So we will have pi minus x u and integration of v sine. Integration of sine is what? Minus cos. So this become what? Cos n ex by their coefficient n. Okay, and minus derivative of this. What is the derivative of this? Minus 1. Derivative of constant term pi is 0 and x is what? Minus 1. Minus x is what? Minus 1. Okay, now integration of this. Integration of this is what? Integration of cos is sine. Sine n x. Minus n is already here, no? So we write here. And divide by their coefficient n, but n is already here. So this is what? N square. Okay, and providing limit 0 to 2 pi. So this equal to what? 1 upon 2 pi. Just simplify. Before applying the limit, we must simplify this bracket. So we will have minus pi minus x cos n x by n, minus minus goes plus, and again here minus. So here sine n x by n square, and providing limit 0 to 2 pi. Okay, so this equal to 1 upon 2 pi. Okay, providing upper limit. What is the upper limit? 2 pi. So negative sign as it is. Okay, and pi minus 2 pi and cos 2n pi by n, and minus sine 2n pi by en square. Okay, now close the bracket. Minus lower limit. So minus n is here and pi minus. So instead of x, we putting here 0. So we have 0 and cos 0 by n, and minus sine 0 by n square. Okay, now close the bracket. So just simplify. So 1 upon 2 pi. Okay, so we simplifying this. So this become what? Pi minus 2 pi. That is what? Minus pi. Okay, and cos even multiple of pi is 1. So this become 1 upon n minus, and sine multiple of pi is always 0. So whole thing will be 0. Okay, whole thing will be 0 and minus here we write here pi cos 0 is what? Cos 0 is 1. So this become 1 by n. Okay, and minus sine 0 is 0. So we have whole thing 0. Just close the bracket. Now again simplify. So 1 upon 2 pi minus goes here plus, and plus here multiply. Now this is, so this become what? Pi by n. So this become pi by n, and minus goes here plus. So this become what? Pi by n. Okay, just simplify. So this is good. Pi and pi, 2 pi. Why this so? Because denominator is same, so numerator will be added. So 1 upon 2 pi into 2 pi by n, and 2 pi will cancel. So this become 1 upon n. So from this you will get bn equal to what? 1 by n. Okay, bn equal to 1 by n. Now substituting all the Fourier coefficient in equation number star. So let us move to the next page first. Now substituting all the Fourier coefficient in equation number star. Substituting all the Fourier coefficients in equation number what? In equation number star. We get f of x, f of x and equal to what is the value of a naught? What is the value of a naught? Yes, can you tell me? You got value of a naught is what? 0. Just write down over here 0 and plus summation running from n equal to 1 to infinity. And what is the Fourier coefficient an? Fourier coefficient an is also 0. So we have 0 cos nx and plus sum running from n equal to 1 to infinity. And what is the Fourier coefficient bn? Fourier coefficient bn is what? 1 upon n. So this is 1 upon n sine nx. Okay, just simplify this. Just simplify. So this is equal to 0 and plus 0 and plus what? Sum running from n equal to 1 to infinity sine nx by n. Okay, so more simplified form, we write this equal to n running from 1 to infinity sine nx by n. Okay, so which is the required Fourier expression of given function. Therefore f of x is can be written as what? We run this series, so we running sine, instead of n we putting 1, so this become sine x by 1 plus sine 2x by 2 plus sine 3x by 3 and plus so on. Okay, but f of x is what? F of x is 1 by 2 f of x is what? 1 by 2 pi minus x, and this is equal to what? Sine x upon 1 plus sine 2x by 2 and plus sine 3x by 3 and plus so on. Okay, we have to what? Deduce the next part. So for this, what I have to do? If I put here x equal to pi by 2, then we are able to do that. Okay, so this become what? Sine pi by 2, but sine pi by 2 is 1, so first term we'll get. Okay, so here second term, instead of x we putting pi by 2, so here 2 and 2 will cancel, this becomes sine pi, but sine pi is 0, so here even multiple of pi by 2 will be 0. Okay, but odd will survive, so just put here we putting x equal to pi by 2 in this expression. Okay, we putting x equal to pi by 2 in this expression, so we will get 1 by 2 pi minus x equal to what? So pi minus, so instead of x we putting here pi by 2, so we just write down pi by 2, so this is pi by 2 and this equal to what? Sine pi by 2 by 1. Okay, and plus sine 2 into pi by 2 by 2 and plus sine 3 into pi by 2 by 3 and plus so on. Okay, so just simplify, so therefore you'll get 1 by 2, just cross multiply 2 pi minus pi, how much? 2 pi minus pi, that is what? Pi by 2. Okay. And this equal to what? Sine pi by 2 is what? 1. So this can be written as 1 by 1 plus this 2 and this 2 cancel. So here sine pi, but sine pi is 0. This term will 0. Okay. And here you will get sine 3 pi by 2. Sine 3 pi by 2 will be what? Minus 1. So this become 1 by 3. Okay. And here will be sine 4 into pi by 2. So sine even multiple of pi by 2 will be 0. So next term will be what? Next term will be plus.
1 by 5.
Yes. So this is 1 by 5 and minus 1 by 7 and so on. Okay. Minus 1 by 7 and plus and so on. Okay. So just simplify this. So this is pi by 4 and this equal to 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 and plus so on. Okay, which is required deduction, which is required deduction, which is required deduction of the expression. This is your expression 1 of expression 1 of which is required deduction of expression 1. Okay, I hope you understood this problem, how to solve. Yes or no, student? Yes.
Yes, sir.
Is this simple or difficult? Is this simple or difficult?
Simple है sir.
हाँ, सिंपल था, आसान था.
सर
देखिए
ओ सर -1/3 है, फिर प्लस 0 रहेगा ना?
जीरो मतलब क्यों रहेगा? जीरो मतलब कुछ नहीं ना, जीरो लिखो या ना लिखो, डजंट मैटर. Just look your question na, what expression we want to obtain, so that will be your required expression ना.
सर
हाँ,
जो हम लोग A0 फाइंड किए थे A0, उस वाली स्लाइड पे जरा चाहिए ना, मेरा थोड़ा लिखना बाकी था.
पीछे जाऊँ.
हाँ हाँ जी सर.
This is your this one A0. You copied it?
जी सर.
Okay. And how much time we have? 5 minutes remaining is there.
Yes, sir.
Okay. Should I give some exercise for you? Okay. Exercise problem you must practice it. Okay. Chaliye, let us give some exercise because the problem will not be completed in within 5 minutes. Okay. So just take exercise so that you can practice the problem at your home. This is last one. Okay. Examples. Examples. Find the Fourier series. Find the Fourier series for the following function. For the following functions. Okay, number one. Your number one is what? F of x equal to e raised to x in the interval 0 to 2 pi, and number two, f of x equal to 1 2 minus pi by x. 1 2 minus pi by x, the first function running from 0 is less than ax is less than equal to pi, less than equal to pi. The next one is what? Pi is running from ax is running from pi to what? Sorry, x is running from pi to 2 pi. Okay, your limit already is what? Your interval is 0 to 2 pi. See this. How to obtain the Fourier expression of this function? What I have to do? Here you will have the function e raised to x. Okay, so first one you determine a naught by using the formula. Okay, and b a n. Your formula will be what? 1 upon pi f of x cos n x and dx. Okay, so if you solve this and your limit is 0 to 2 pi. Okay, 1 upon pi 0 to 2 pi. Here f of x is what? E raised to x and cos n x. Okay, cos n x. Here you will use the standard formula of what? E raised to ax into cos bx dx. Okay, integrate this. Use the standard formula of this. Okay, already written the formula in the last lecture. You have seen what is the formula for this. Okay, similarly you can obtain bn. For bn के लिए आपको क्या लिखना पड़ेगा? 1 upon pi 0 to 2 pi. Okay, e raised to x. Here will be sin n x. Okay, sin n x dx. Here again you will use the standard formula e raised to ax sin n, sorry, sin b x and dx. Okay, so here this will be what? Your b. Your coefficient of 1 will be what? A. Okay, by using these two formula you can determine the Fourier expression of the function e raised to x. I hope you understood how to find the Fourier expression of the function 1. हो जाएगा ये?
हो जाएगा।
प्रॉब्लम नंबर 2, इसको आपको कैसा करना है? a naught. Okay, you have formula for a naught 1 upon 2 pi. So your formula is 0 to 2 pi. Okay, f of x and dx. So this can be written as 1 upon 2 pi, and just put here bracket and 0 to pi. Your first function running from 0 to pi. So we have 1 dx and plus your second function running from pi to 2 pi. So pi to 2 pi. Your f of x is what? And 2 minus pi by x and dx. Okay, just integrate this and you will get a naught. Okay, value of a naught. Similarly you find a n by splitting your formula into two parts. The first part is what? Function 1 for the limit 0 to pi. Second part is what? Your function 2 minus pi by x for the limit pi to 2 pi. Okay, by using this technique you can determine a n. So that will be what? A n star, some value you will get na. So this is similarly you can determine bn. Okay, bn. So I hope you will do this problem at your home. You understood how to find? Yes or no, students? Please tell me.
Yes, sir.
So please do this problem at your home. Okay.